All right, welcome back. We're still on section 3.4. 3.4. I really should write that at the top of my notes. Still on section 3.4. Let's continue. So let's try practicing composing functions with graphs. We've done function composition with equations. We've done it with charts. Let's try it with graphs. All right, the very first one says m of k of 1. And as you know, I like to rewrite this as m of k of 1. And again, we work on the inside first. So we need to find k evaluated at 1. This is my k of x function. So if I put an input of 1, my output is going to be 3. Right? Input of 1, this is the point 1, 3 on my graph. So an input of 1 gives an output of 3. So this means find m of 3. Go over to my m graph. Here's my input of 3. Gives an output of -6, because this is the point over 3 down 6. So m of 3 is equal to -6. All right, let's try the next one together. Oops, what have I done? I've done terrible things. I don't know how that happened. I was trying to erase, but it wasn't really working. All right, let's erase this. And let's try m of k of 2. So again, we start on the inside and we figure out what is k of 2. Here's my k function. I go to 2, and my output is also 2. This is the point 2, 2. So this is equal to m of 2. I go to m, evaluated at 2, and this is the point 2, -1. So my output is -1. All right, I'd like you to pause the video right now and try the next two. All right, welcome back. I hope you were able to solve these. Let's do them together. K of m of 0 equals, looking at the m function now first, m of 0 is +3, so that's k of 3. K evaluated at 3 is +1. K of m of -2. M of -2 is -1. K of -1 is 5. All right, so it's very similar to the process of finding it using the chart. You just have to read those ordered pairs off the graph. Oops. All right, I'm just all over the place here. Let's go ahead and try and find the domain of a composition. We have two functions, v of t and h of t. And first, we want to find v of h of t and h of v of t, and then we'll talk about their domains. All right, so let's find v of h of t first. V of h of t is going to be putting the function root t plus 2 into the function v. So this will be everywhere I see a t, now I put square root of t plus 2. So this is 2 over the square root of t plus 2. Let's try h of v of t. So that's h of 2 over t. So that's equal to square root. Now everywhere I see a t, I put 2 over t plus 2. All right, so I found my function composition. Let's think about their domains. Well, let's look at their domains individually first, and then we'll think about their composition, because I think that will be helpful. If we look at the function v of t, and we think about its domain, remember this, there's two things you check in domain. You check square root of a negative number, and you check don't divide by 0. So this one falls into that second category, don't divide by 0. So for this guy, we need t to not be equal to 0. So domain is going to be the set of all t such that t is not 0. Everything but 0. Let's think about the domain for h of t. Well, we don't have to worry about dividing by 0, but we do need to worry about taking the square root of a negative number. We need the bit, excuse me, under the square root sign, t plus 2, to be greater than or equal to 0. Solving that linear inequality means that t needs to be greater than or equal to -2. So the domain for this function is the set of all t such that t is greater than or equal to -2. All right, so let's look at our function compositions. Let's look at v of h of t first. If we look at v of h of t, it's 2 divided by the square root of t plus 2. So when we look at this denominator, the square root of t plus 2, we still need the same domain, right? We can't have that be great. We can't have t be less than negative 2 because we'll still be taking the square root of a negative number, right? So for v of h of t, one thing, the domain that we're thinking about, one thing that we need to think about is we need t to be still greater than or equal to negative 2. That's one item. But now we also are dividing, right? Because we still have that v of t function. And we need that denominator to not be equal to 0. Well, when would square root of t plus 2 be equal to 0? Right? When would that happen? Well, if we square both sides, that's when t plus 2 would be equal to 0, or t is equal to negative 2. So the second restriction is we need t not equal to negative 2. Because if we have t equal to negative 2, we plug it into that function, the denominator would be 0. So we need both those things together to think about the domain for our new function composition. We need one, t to be greater than or equal to negative 2, and we need t to not be equal to negative 2. So that can be simplified down to the domain is the set of all t such that t is just greater than negative 2. I'm running out of space on the side of my wall there. We need to just exclude that negative 2 endpoint. All right, why don't you try the domain of h of v of t and come back, pause the video and come back. All right, let's look at h of v of t's domain together. Well, we still, if we look at the inside of this function, right, h of v of t, we can't have t be equal to 0. T cannot be 0 because we're going to be dividing by 0 right off the bat. And we also need 2 over t plus 2 to be greater than or equal to 0 because otherwise we'd be taking the square root of a negative number. So that means 2 over t, oops, let me try t. 2 over t needs to be greater than or equal to, add negative 2 to each side. Let's do the cross multiply, let's multiply both sides by, yeah, let's just multiply both sides by t. I didn't mean to put that down. Multiply both sides by t. We get 2t is greater than or equal to, gosh, I'm messing up big time here. We mean, timeout, cancel. 2 is greater than or equal to negative 2t. Divide by negative 2. Switch the sign. We need t to be greater than or equal to negative 1, right? If t is greater than or equal to negative 1, then 2 over t plus 2 will be greater than or equal to 0. Plug negative 1 in there really quick. Let's just check this. If we plug negative 1 there, we get 2 over negative 1, which is negative 2 plus 2 gets us 0. If we pick something bigger than negative 1, like 2, we divide 2 by 2, we get 1. 1 plus 2 is greater than or equal to 0. So that works. All right, so this is our second restriction. We need t to be greater than or equal to negative 1. I'll have to rewrite that. T greater than or equal to negative 1. We need that for the square root part. We need t to not be 0 for the dividing part. So let's think about what the domain is here. The domain would be the set of all t such that t is greater than or equal to negative 1, and we also don't want 0. T is not equal to 0. So you could write it this way. If you wanted to write it in interval notation, it would be negative 1, square bracket, negative 1, t greater than or equal to negative 1, up to 0, but don't include it, union that with 0 to infinity. That's the way you would write it using interval notation. So the domains are a little bit trickier with function composition, and this was a particularly tricky example. If you were composing, say, a linear function with a quadratic function, you wouldn't be having these problems because both of those domains are all real numbers. I picked a really tricky one that had the square root problem and the divide by 0 problem. All right, let's talk about decomposing. This is sort of like a puzzle. How do you figure out the functions that went together to make this function composition? So let's look at an example. We have this function h of x equal to 4 divided by x plus 2 squared. We want to think of it as two functions that were composed together, f of x and g of x. Is there a way that we can do this? Well, it takes a little bit of practice, but we have an outer function, which is f of x, so this is my outer function, and I know that because it says that f of g of x is h of x, and this is my inner function, g of x. So if I want to write this as an outer function and an inner function, I usually try to just step back from my function, just look at it from a distance, and I see it's 4 over something squared. If I look at h of x, it's 4 over some stuff squared. So my outer function is the big picture. So f of x is going to be equal to 4 over x squared. And h of x is going to be my inner piece. The inner piece of this function, instead of just x, is x plus 2. So there's two functions together, and I can check that f of g of x is going to be equal to f of x plus 2, which is 4 over x plus 2 squared, and sure enough, that equaled h of x. So when you decompose functions, it does take a little bit of practice, but really look at what the big thing is, 4 over something squared, that's what I made my outer function, and what did I put into that? G of x is my inner function. All right, that's it for section 3.4.